Welcome to the EVPN routes module. By the end of this module, you should be able to describe unicast and broadcast EVPN routes. The Type 1 route, or Ethernet Auto-Discovery route, is used to propagate ESI information to remote VTEPs when a non-default ESI is configured for a site. This is used when multi-home sites are attached to the EVPN-VXLAN network. Once you have configured a non-reserved ESI value on a site-facing interface, the provider edge, or PE, advertises an Ethernet Auto-Discovery route to all remote VTEPs. The route carries the ESI value and the ESI label extended community. The community contains the single active flag. This flag enables the remote VTEPs to detect whether they can load share traffic over the multiple links attached to the site. If the single active flag is set to 1, that means only one link associated with the Ethernet segment can be used for forwarding. If the single active flag is set to 0, that means that all links associated with the Ethernet segment can be used for forwarding data, known as active-active forwarding. Juniper Networks devices only support active-active forwarding, which always sets the flag to 0. When a remote VTEP, leaf 3 in the example, receives the Ethernet auto-discovery routes from leaf 1 and leaf 2, it now detects that it can use either of the two VXLAN tunnels to forward data to MACs learned from Site 1. Based on the forwarding choice made by Server 1, maybe leaf 1 is the only VTEP attached to Site 1 that learns Server 1's MAC address. Hence, leaf 3 may have only received a MAC advertisement for Server 1's MAC from leaf 1. However, because leaf 1 and leaf 2 are attached to the same Ethernet segment as advertised in their Type 1 routes, leaf 3 determines it can get to Server 1's MAC through either leaf 1 or leaf 2. You can see in the leaf 3's MAC table that both VXLAN tunnels have been installed as next hops for Server 1's MAC address. Another benefit of the Ethernet auto-discovery route is that it helps to enable faster convergence times when a link fails. Normally, when a site-facing link fails, a VTEP withdraws each of its individual MAC advertisements. Think about the case where there are thousands of MACs associated with that link. The VTEP must send thousands of withdrawals. When the Ethernet auto-discovery route is being advertised because the ESI statement is configured on the interface, a VTEP like leaf 1 can send a single withdrawal of its Ethernet auto-discovery route, and leaf 3 can immediately update the MAC table for all the thousands of MACs it has learned from leaf 1. This improves convergence times. The Type 2 route has a very simple purpose, which is to advertise MAC addresses. Optionally, this route can advertise a MAC address and an IP address that is bound to that MAC address. Leaf 1's EVPN VTEP learns MAC addresses in the data plane from Ethernet frames received from attached hosts, Server 1 in the example. Once leaf 1 learns Server 1's MAC address, it automatically advertises it to remote PEs and attaches a route target community. Leaf 2, another EVPN VTEP, upon receiving the route must determine whether it should keep the route. It makes this decision based on the received route target community. To accept and use this advertisement, leaf 2 must be configured with an import policy that accepts routes tagged with the route target community associated with the EVPN instance, or EVI. Without a configured policy that matches on the route target, leaf 2 would discard the advertisement. So, at a minimum, each EVI on each participating VTEP for a given EVPN must be configured with an export policy that attaches a unique target community to MAC advertisements. It also must be configured with an import policy that matches and accepts advertisements based on that unique target community. This EVPN route is very simple. The route informs remote VTEPs of how broadcast, unknown unicast, and multicast or BUM traffic should be handled. This information is carried in the Provider Multicast Service Interface, or PMSI tunnel attribute. It specifies whether protocol-independent multicast, or PIM, or ingress replication is used, and the addressing is used to send the BUM traffic. In the diagram, leaf 1 advertises that it is expecting and using ingress replication, and that leaf 2 should use 10.2.2.2 as the destination address of the VXLAN packets that are carrying BUM traffic. EVPN has default split horizon rules to avoid unnecessary traffic replication and to prevent forwarding loops. If a VTEP receives a bum packet from a local host, for example, server 3 attached to leaf 3, flood the packet to local hosts in the same VLAN, flood the packet to remote VTEPs in the same VLAN, and do not flood the packet to the original host device. Split horizon rules are also in place for traffic received from remote PE devices, leaf devices. If a leaf, VTEP, or a PE receives a bum packet from a remote leaf, VTEP, or a PE, for example, leaf 3, flood the packet to local hosts in the same VLAN, and do not flood the packet to the remote leaf, VTEP, or a PE device. The Type 1 Ethernet auto-discovery route can enable multipath forwarding when a site is multi-home to 2 or more VTEPs. This advertisement works well for detected unicast traffic. However, the example shows what happens when Leaf 1 must send bum traffic to remote VTEPs. In the diagram on the left, Leaf 1 makes copies of the bum packets and unicasts them to each remote PE that belongs to the same EVPN. This causes server 2 to receive multiple copies of the same packets. In the diagram on the right, Leaf 3 receives bum traffic from the attached host. It makes copies and unicasts them to the remote VTEPs, which includes Leaf 2. Because of the default split horizon rules, Leaf 2 forwards bum traffic back to the source, which creates a loop. Electing a designated forwarder for an ESI solves these problems. To fix the problems described in the previous example, all the VTEPs attached to the same Ethernet segment elect a designated forwarder for the Ethernet segment, 2 or more VTEPs advertising the same ESI. A designated forwarder is a device that is elected to forward traffic to an Ethernet segment. A designated forwarder is elected for each broadcast domain. Remember that an EVI can contain 1 or more broadcast domains or VLANs. The Ethernet segment route, Type 4, is used to help with the election of the designated forwarder. Once an Ethernet segment identifier or ESI is configured on an interface, the virtual tunnel endpoint or VTEP advertises the Ethernet auto-discovery route Type 1 and also an Ethernet segment route Type 4. The Type 4 route solves 2 problems: the designated forwarder election process, and it helps add a new split horizon rule. In the example, Leaf 2 and Leaf 3 advertise a Type 4 route to every VTEP that belongs to an Ethernet VPN or EVPN. However, the route is not tagged with a target community. Instead, it is tagged with an ES import target community. The ES import target community is automatically generated by the advertising VTEP and is based on the ESI value. Since Leaf 1 does not have an import policy that matches on the ES import target, it drops the Type 4 routes. However, since Leaf 2 and Leaf 3 are configured with the same ESI, the routes are accepted by a hidden policy that matches on the ES import target community that is only determined by the VTEPs attached to the same Ethernet segment. Leaf 2 and Leaf 3 use the originator IP address in the Type 4 route to build a table that associates an originator IP address, that is, the elected designated forwarder, with a VLAN in a round-robin fashion. After the election, if a non-designated forwarder for a VLAN receives bum traffic from a remote VTEP, it drops those packets. And route Type 5 decouples the EVPN route. EVPN route Type 5 decouples the IP prefix advertisements from the MAC or IP advertisement routes in EVPN. This enables the clear advertisements of IPv4 or IPv6 prefixes in a network layer reachability information or NLRI message without MAC addresses. Since the route type differs from the MAC or IP advertisement route, the current procedures described in EVPN Type 2 do not need modification. A flexible implementation is enabled where the prefix can be linked to different types of overlay or underlay indexes, overlay IP addresses, overlay MAC addresses, overlay ESIs, underlay BGP next hops, and so on. An EVPN implementation not requiring IP prefixes can simply discard them by looking at the route type value. A Type 5 route, also called the IP prefix route, is used to communicate between data centers when the Layer 2 connection does not extend across DCs and the IP subnet in a Layer 2 domain is confined within a single data center. In this scenario, the Type 5 route enables connectivity across data centers by advertising the IP prefixes assigned to the VXLANs confined within a single data center. Type 2 routes are advertised between data centers. In this example, no Type 2 routes are advertised between data centers. The Data Center Interconnect, or DCI, creates a new VNI, creating a virtual broadcast domain between the DCI devices, which can route traffic to an IP prefix destination using the inet.0 routing table. Each data center is deployed using edge-routed bridging, or ERB. A VXLAN tunnel is created between leaf 1 and border leaf 1. Since server 2 is in a different broadcast domain than server 1 is required to send traffic destined to server 2 to the default gateway, which is leaf 1. Once traffic reaches the IRB interface on leaf 1, a route lookup occurs and determines that the destination network 10.1.2.0/24 is reachable through the new VTEP tunnel that crosses the DCI. Router border leaf 2 is listed as the next hop for the Type 5 route prefix that advertises reachability to the destination. Border leaf 2 receives the forwarded traffic across the VXLAN tunnel, removes the VXLAN header used for the DCI link, and adds a new VXLAN header before forwarding it to leaf 2. Gateways that share the same IP address for a subnet. Shown is an example configuration on an MX series router. If both Spine 1 and Spine 2 are configured in this manner and use the same virtual gateway address, both devices will share the same virtual IP address and the same virtual MAC address as shown here. The Spine nodes will each advertise that MAC address to the other VTEPs. The remote VTEPs can be able to load share traffic over the multiple paths to the same virtual MAC address. In the event that one of the gateway devices fails, the remaining gateway continues to service traffic that is forwarded to the virtual IP and MAC addresses. The EVPN route type. Here is a summary of the EVPN route type supported by Juniper networks.